Hello, my name is Ray. I'm the Ray in the Ray Code. Welcome to the Ray Code. Today we'll explore the chain of responsibility design pattern in Java. The full source code is in the link below. If you enjoy learning design patterns, please subscribe and leave a comment with your thoughts or questions. Also, invite a friend to our development community. The chain of responsibility design pattern enables decoupling between senders and receivers by allowing multiple objects to handle a request. The core idea is that a request is passed along a chain of potential handler objects. Each handler decides either to process the request or pass it to the next handler in the chain. Why Java programmers should study the chain of responsibility design pattern. Request handling. It simplifies request processing by allowing multiple objects to handle a request dynamically. Decoupling logic. The pattern decouples sender and receiver, enhancing maintainability and flexibility in the evolving Java codebase. Dynamic responsibility provides the ability to dynamically define and modify the chain of responsibility at runtime. Error handling. Useful for creating robust error handling chains where multiple modules can validate or log error sequentially. Command validation facilitates validation of user commands or inputs by passing them through a series of validation handlers. Scalable workflows. Make scalable workflows possible by adding or removing handlers without altering existing processing logic. Middleware simulation simulates middleware-like functionalities such as authentication, logging, and rate limiting in server-side Java applications. Let's take a look at the ORM UML diagram for the chain of responsibility with a focus on Java students. Handler defines the interface for handling requests, stores a reference to the next handler, forwards requests if it can't handle them. Concrete handler handles requests it is responsible for, decides whether to process or forward, passes unhandled requests to successor. Client sends requests to the first handler, does not know which handler processes, relies on the chain for handling. If this video is helping you understand some programming concepts, leave a comment and tell us about it. Hello, I'm Ray, the Ray in the Ray Code. Imagine a chain of sandwich makers, each making specialized, adding one specific ingredient. Each maker specializes in adding one specific ingredient. They don't have to that ingredient. They pass the sandwich down the line to the next expert. This will be an example of the chain of responsibility design pattern. I'll be using Java. We start by creating a sandwich maker class. Let's make it an abstract class. Like that. We add a particular sandwich maker variable named nextMaker. We add a method to set nextMaker which accepts nextMaker object. We add an abstract handle to add ingredients which accepts a string ingredient argument. Now, let's create a bread maker class. The bread maker class will focus on the bread. We extend it with the abstract sandwich maker class, which requires us to have the add ingredient method, so we use a code auto generator. Inside the add generator method, we add some code to decide whether to toast the bread or not. If not, we pass the sandwich along. Let's create a lettuce adder class. Like the bread maker class, we need to extend this class with a sandwich maker abstract class. We use a code generator to add the missing method and adds the add ingredient method, which takes an ingredient that will be passed in. We test to see if the ingredient is lettuce. If so, we add it and then pass it along the chain. The next in our assembly will be the cheese spreader. The cheese spreader will of course spread cheese. We extend the cheese spreader with a sandwich maker abstract class, which requires the use of an add ingredient method. So we auto-generate. If the object we pass in is cheese, we add a thick slice, else we hand it off. I think we are ready for a demo. We go to main. We add a new bread maker, a new lettuce adder, and a new cheese spreader. With the bread maker, we set set the next maker in the lattice adder, and the lattice adder we set the next maker passing the cheese spreader object. We write to the console making the sounds with bread, and then we add the ingredient. We write to the console making the sounds with lettuce, and we add making sound with pickles. Now let's run and see what we have. We have bread maker toasting the bread nice and crispy, making a sandwich with lettuce. Bread maker, I only deal with bread, passing on cheese spreader, cheese please, handing up, cheese spreader, cheese please, handing up. Making a sandwich with pickles. Bread maker, I only deal with bread, cheese spreader, cheese please, pass it off, cheese spreader, cheese please, handing off. In this musing sandwich shop, the bread maker only toasts bread. Lettuce editor is all about the crunchy green. Cheese spreader, well, they're here for the cheese pull. If you ask for the pickles, though, the sandwich just goes through the chain with everybody passing it on. Puzzle. My name is Ray, always code with smile. SWOT analysis of the chain of responsibility design pattern for Java students. S. Strengths. Dynamic workflows. Supports dynamic and flexible request handling workflows. Extensibility. Easily extends by adding new handlers to the chain. Decoupling. Decouples senders from receivers for clearer code. W. Weaknesses. Execution overhead. Long chains may degrade performance. Complex debugging. Debugging large or dynamic chains can be challenging. Order dependency. Misordered handlers may lead to unexpected results. O. Opportunities. Middleware pipeline. Fits well in designing middleware chains in Java frameworks. Event handling. Useful for handling events dynamically in GUIs. Authorization chains. Implements step-by authorization in enterprise applications. T. Threats. Scalability risk. Excessively long chains can hinder scalability. Mismanagement. Mismanaging chain components might introduce unexpected failures. Similar solutions. State or observer might suit specific use cases. And that is the chain of responsibility design pattern using JavaScript. If this video is helpful and helped you understand the design pattern, please like this video and subscribe and support the channel. You can find a full list of the code in my GitHub site. Also, an article that I post on the raycode.org. Links are in the description. Thanks for watching, and I'll see you in the next design pattern.